afternoon, fellas. This is Miss Anderson here, and we are starting our unit on transformations. And so the first thing that we're going to do is take a look at our lesson. If we look on Google Classroom, sorry, I need to go back to where I was. On our lesson, we have something. I don't think I want to do it this way. Oh, here we go. So there's a Jamboard that says which one doesn't belong. So I will put this link on our Google Classroom, and you're going to see some shapes on there, and you're going to which one doesn't belong looking at the shapes. So it'll be 4 different shapes. We're in another class now, but that's what we're going to do. So you're going to answer that first. Which one doesn't belong? Moving forward, our learning goals for today says, I can decide which type of transformations will work to move one figure to another. And I can use grids to carry out transformations of figures. So the first part of transformations is translations. So translation is something that moves every point in a figure a given distance in a given direction. The diagram shows a translation of figure A to figure B using the direction and distance given by the arrow. So if you're looking at this, you can see that there's an arrow from A to B. But one of the other things I want you all to notice is that the shape never changes directions. If you look at these corners, they're still pointing the same direction. It just moved forward. So just think about the electric slide. Another part is called a reflection. So a reflection across a line moves every point on a figure to a point directly on the opposite side of the line. The new point is the same distance from the line as it was in the original figure. So let's look at the figure right here. We have her shape A, and then we see it on B. So imagine if this is a mirror. If you have a mirror, you're looking in a mirror, you see yourself, but it's flipped. So looking at the points, here's one point going that way. The mirror reflection will be the point going that way. Here's the corner. Here's the corner. You can't really see the edge, but there's the other edge. So reflection, just think of a mirror. A rotation. A rotation moves every point on a figure around the center by a given angle in a specific direction. This diagram shows triangle A, which is this one, rotated around center O, here's O, by 55 degrees clockwise to get triangle B. So looking at, here's the angle right here, and as it's turning, we get the B. And the degrees that it's turning is 55. That's what the little circle means, 55 degrees. So just think about it going clockwise. This is how, when you have a clock on a watch, the time goes that way. That's clockwise. So it's a rotation. And here's clockwise. Clockwise means to turn the same direction as the hands of a clock. The top turns to the right. This diagram shows figure A turned clockwise to make figure B. So if you're starting right here in this corner, you look at the arrow, it's turning, 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 turning. And by the time it gets here, it makes this shape. So again, you're going to the right for clockwise. So the opposite of clockwise is counterclockwise. Counterclockwise, if you're looking at this arrow, is going to the left. So it says counterclockwise means to turn opposite of the way of the hands of a clock turn. The top turns to the left. This diagram shows figure A turned counterclockwise to make figure B. So basically, here's the starting point. It's turning, 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 turning backward. It stopped right here, and that's how we have figure B. Kind of looks like a reflection, but it's not. So counterclockwise is going the opposite direction. An image. An image is the result of translations, rotations, and reflections on an object. Every part of the original object moves in the same way to match up with the part of the image. So basically, it says everything's the same. Every part of the original object moves in the same way to match up. So if this was to be going back this way, it would match up perfectly. It would lay right on top of it, and that's how you know it's an image. So it's not like a mirror reflection. It means it's the exact same size. Okay, so again, if you start here, moving, 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 it's going to fit right on top of triangle F, well, D, E, F. This is A, B, C. It'll lay perfectly on top of it. All right. So the learning goal says I can decide which type of transformations will work to move one figure to another. And I can use the grid. That's just what we are doing today. And what I just did was the definitions. So what you all are going to see is something called GeoGebra. And that's actually going to be in our Google Classroom. I want you all to do problems 1 and 3 to practice. Okay? And I'll be able to see when you've done it. Okay? So, wrapping this up, what are important things to keep in mind when we want to do a translation, a rotation, and a reflection? So remember, translation is a slide. We are sliding from one part to another. A rotation is when we're turning clockwise, like the mouse is moving, turning clockwise. And a reflection, think about a mirror. So whatever it is on one side of the mirror, it's going to be the exact opposite side on the other side. All right, so what is something new that you learned today about translations, rotations, and reflections? We'll talk about that on Thursday. And then describe 2 different kinds of grids we saw. What was the same and what was different about them? All right. So the exit ticket is you all will have a cool down that you'll need to do by Thursday. And a reminder is to turn in all your work on Google Classroom. That's what GC means. If you are falling behind on work, reach out for help with deadlines and assignments. I also put in our group how to your weekly checklist so you know what you have to do, okay? All right, so that's going to be wrapping up. So closing, you have to do the GeoGebra assignment and the exit slip with a cool down. All right, thank you.